Good afternoon, everyone.
Good afternoon, ma'am.
Good afternoon, ma'am.
Yeah. Okay, so what did we see so far? So we have seen this first experiment. So this is over. Okay. Demonstrate different representation of numbers in Python is over. And also we have seen this part yesterday, wherein we try to perform operations on numbers, and also we try to perform the arithmetic operations on the complex numbers. Okay, so in today's class we'll look into the third exercise. So the third exercise is all about so this third exercise, this is what we are going to see today. So this is all about develop programs to demonstrate decision making and looping structures in Python. Okay, so let us get started. Okay, fine. So I'm just getting into the program. So it is decision control. So I'm just giving dec.py. So I'm creating a file. So this is my G editor, wherein I'll be working on to demonstrate the decision making and looping structures. To just give you a brief introduction on decision making and looping structures, so which we already have seen in the first unit. So it was pretty clear. So wherein I have explained you what are the various decision making constructs in Python and also the looping structures in Python. So I hope my voice is clear. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
So now coming to the decision statements, making statements. So what happens with the decision making statements is that the decision making statements will alter the flow of execution. Say I have an if over here and there is a condition, for example, and based on this condition, if the condition is true, then the set of statements that are within this if will execute. Say I have statement 1, then statement 2, and then I have statement 3, and then I have some elif over here and some condition here, and then I have certain statements like S4 and then S5 and all that. So now what is the concept with the decision making is that if this condition inside this if block is true, then what happens is this if block executes. Okay, so the flow is different. And since this condition has become true, what happens is this else elif parts will never execute. So these statements S1, S2 and S3 will execute because the condition has become true. Now say for example, this condition became false. Okay. So when this condition became false, what happens is this 1, 2, 3 statements will never execute. And then this S5 and all that will execute if this condition becomes true. So the path of execution will depend on whether a particular condition is being true or false. That is what is called as decision making. Okay, so a path execute అవ్వాలి అన్నది the condition మీద depend అయి ఉంటుంది కాబట్టి. So this is what is called as decision making process inside your program. So I think I needn't throw much light on this concept because you already have learned this concept in your C programming. Let us look into what are the keywords that are associated with decision making. The first keyword is if, and the second keyword is elif, and the third one is else. Okay, so if, elif and else. Now there are certain rules like how you need to write. So if can be individual, like you needn't associate an else with if possible. And if you just want an if inside your program, you can simply have an if inside your program. And if should always follow with a condition, and this condition will evaluate to be true or false, and there should be a colon after the condition. And the if block starts with an indentation. You can see that I have given an indentation over here. So whatever you want to write, you should be writing only after the indentation. So this S1 and S2 will form the block of the if. Okay, so this forms the block. How can you say that this is the part of the if block? Is because there is an indentation over here. Okay, right. So this is how you can write. You can have an if simply like this without an else. Okay, this is totally valid. And if this condition becomes true, then S1 and S2 executes. If this condition is false, then it goes to the next statement, immediate statement after if. which is S3. Okay, right. Skipping S1 and S2, it goes to S3 if this condition is false. Okay, so this is regarding if. If can also be suffixed, or it can always be followed with an else. Okay, fine. So there can be an else, or they can also be an elif. Okay, fine. It can simply be if and else. Okay, if can be individual, meaning that then needn't be an else after if, it's not mandatory, but else should always have an if or an elif before it. So this is mandatory. Okay, right. So else should always have an if or elif before it, but if can have or needn't have an else after it. Okay, so these are certain rules that we need to know before working with this particular example. And the third one is like elif. Where do elif come? Okay, so elif will come in between this if and else. Okay, I can have n number of elifs like this, and then finally I can have an else, or I needn't have an else. Okay, fine. But here the point is this elif should be having an if before it. It cannot be individual. Okay, so elif cannot be independent. In a program, it should be having an if preceded before it, and else it can be there after elif, or it cannot be there. Okay, it's both the ways, either ways it's valid. Else being there and else not being there is totally valid. Both the statements are correct. Okay, fine. So this is regarding this, and having multiple elifs, we say the concept to be nested, we say the concept to be ladder. Okay, so if and elif ladder, because there are so many elifs over here. So if followed by n number of elifs, you call that as a ladder. Okay, right. And if can also have an if inside it. So I can have an if, and then this becomes the outer if, and this becomes the inner if. So the inner if gets a chance to execute only if the outer if condition becomes true. If the outer if condition is false, then this internal if will not get a chance. And you can also have this individually, can be if or a ladder of if and elif, or it can be a if and an else, and all that is possible inside also, anywhere outside also. Now, how many ifs you can nest? There is no limit on how many ifs you can nest. You can have n number of nestings of if possible. But there is one point that being programmers we need to remember is, do not make your program more congested and more complex by having lot of loops, or nesting of loops, or nesting of ifs and all that. Anyway, nesting of loops will increase the time complexity of your program. So always we need to see to it that there are you solve it with a single while loop or a for loop or a single loop. Once you start nesting, what happens is, for two loops, one inside the other, will make it n square. Okay, so the complexity will be quadratic time complexity, which is not advised at all. And that's the reason your insertion sort and all that will have an n square time complexity. Now, coming to if I just want if it is 3 loops, like for example, for matrix multiplication and all that, you will be having 3 loops nested. Okay, for outer for, then the middle for, and then the inner for. There it becomes, the time complexity becomes n cube. Okay, so n cube, n to the power of something which actually is not considered to be efficient programming. So you always need to make it a point that for look wise also, the look and feel also, the program should be as simple as possible. And also for execution also, the program should be as simple as possible. Nesting is possible, but try to avoid it in your program. If your algorithm leads you to a nested if, and it is must for you, else you cannot solve it, you can have it, but always look for an alternative, not to nest the loops and also the conditions. Okay, so this is from my side, being an experienced coder. I would just like to give you that tips. Okay, fine. So this is regarding your decision making. So these three are there. Anyways, I explained you the rules of how to use them, syntactical rules. So we already have seen how to use them in your program. Now let us start working with certain examples. Okay, so the first example that I'm going to show you is a nested is a ladder. Okay, so elif ladder. So herein I am trying to read a string, and once I read in the string based on the content of the letters content in the string, I'll be saying whether it is having all letters or all numbers that all, or the string is having a combination of letters and numbers. So that I'm going to do in this program. So I think the problem statement is clear with you. So let me start writing the code. So I'm saying C is equal to, so I say input, so I'm taking an input over here. So I'm not typecasting it to be str or whatever, because input generally takes reads in a string. So I needn't specifically typecast it, because the input itself will be a string. So I'm saying this is what I'm doing to read in the string. Once I read the string, so now I am trying to check on what is it. So I'm saying C dot is digit. So is digit is a inbuilt method which will actually check whether the given string contains any numbers, and not only checks for numbers, it will see to it that the provided string is all numbers or not. Okay, so if the given string is all numbers, like for example, if I say that, like for example, if I say I have given a string as 1, 2, 3. Okay, so 1, 2, 3 is all numbers. Okay, of course it's a string, but in the string I do have numbers. Please mute your speakers, all of you. Somebody is causing disturbance to the class, and I totally, I mean, will not appreciate such a thing. Okay, it means that you are away from your terminals and you are not following the class. Well, okay, so what I am talking about, so this is my string, so which is 123. And 123 is total numbers. 1 is a number, 2 is a number, and 3 is a number. And say I have S associated with 1, 2, 3, then this is all not numbers. Okay, so I have combination of numbers as well as letters. So in this case, this is digit will return a false. Okay, so it will return true only if all the letters, characters in the string are numerical values. It can be 3, 4, 5, or it can be 7, 9, and a 1 and a 0. So here this is a string, but all the characters in the string are numbers. So in that case, this is digit will return a true. Okay, well, fine. So this is what I'm going to do. So so I need to put the indentation. So I'm putting a 4 spaces over here, and then I'm writing a print statement. If this condition becomes true, what need to print on the screen? So I'm mentioning. So I'll say C comma. I'll say the string is all digits. Okay, so I'll simply say that C comma, and I'm saying string is all digits. Okay, so this is what I'm mentioning here. And if this condition is false, because I don't know what the user will be giving, so we cannot predict the user's behavior of giving the input. So he can, or he or she can give all digits, or he or she can give all characters, or he or she can give all a combination of characters and also numbers. So we don't know what will come our way. So we need to write the conditions for which satisfy any kind of input that the user gives. So the first one will execute if the user is giving all the digits. In the second case, I am checking on whether all the characters are number letters. So for that, you're having method which is called as is alpha. Is alpha checks whether all the characters are from the alphabet, or not. So if all the characters are from the alphabet, all are letters from the alphabet, then this condition becomes true, and the corresponding elif block will execute. Wherein there is only one statement which I'm writing, the print statement. This gets execute if is alpha returns a true. So I'm saying the string contains. Okay, so I'll just copy this. Okay, so the string is all letters. Well, fine. And now I'm writing another elif wherein I'll check whether it is alpha numerical. So I'm saying all num. So this is another method which is actually used to this method will check whether the numbers. Okay, so the string given by the user is having combination of letters and numbers. So if there is a combination like that, then this condition will become true. Do not forget to give the indentation. So it is very important because that defines the block. So like in C, you do not have open starch brackets and all that. So you do not have all that. Okay, so you just need to give spaces, indentation properly. Fine. So I can still stop my program here, but if you want to, you can have an else. This is optional. It's not mandatory to have. So I'm saying print, and then I say thank you, or I'll say give another one. In case if it is not falling under these things, then I'll say give another string and try. Okay, so I just want to mention something. You can also skip this if you want to, but you can have it. But remember that it cannot be in the middle of this if and elif and all that. It should be the last one if else is there. Fine. Now that I have finished writing, so what is the concept over here? We are trying to see the concept that we are going to learn from this is a ladder. Okay, so what ladder? It is an elif ladder. Okay, so this is what we have seen. Along with the elif ladder, we have also seen how to give the syntax of if and elif, and how to give a condition and followed by a colon, and then the indentation that I have given here. So we learned many things in a single program here. Okay, fine. Now I am saving this program and I came out of it. So I hope everybody can see the terminal now. Can you see the terminal? Somebody?
Yes,
Yes. Okay. So I am executing my program. So you can see it's asking me to enter a string. I'll start from the beginning, from the first if, to show you how it works. So I have given a string over here, so which is 3, 4, 5, 6, 1 and all that. So which condition gets satisfied?
first condition, ma'am.
The first one. What is it? What's the name of the
Is
condition?
digit, ma'am.
Is digit. I am just trying to make you know the method. Okay, fine. So it is telling me that the string is all digits. Okay, right. Let me check another path of execution where I'm giving all characters. So you can see that Sudha, the string is all letters. Okay, so they belong to letters of an alphabet. Okay, right. And the next one is, let me give a combination of it. So I'm saying Sudha 1, 2, 3. So okay, is I should give that. Okay, fine. I think I didn't give this. Okay, so it should be is all num, right? How it works. Fine. Okay, right. So I'm giving a combination of letters and numbers. So you can see that the string is all letters and numbers. Okay. So you can see that for different kinds of input, different paths on different code snippet gets executed. So that's the reason why this concept is called as decision making. Right. So we'll see another example from the third experiment. So which is nested if. So wherein I'll be finding out the largest among the three numbers. So let us start working on it. So I'll take the same. Program and I'll write the code. So which my A sections, B section students already know because I made these videos and they have already worked on it. But this will be a revision for you anyway. Okay, right. So I said enter A. So I'm just picking on the value of A from the user, and in the similar way, I'll be picking the value of B and C from the user. So we don't know what will be the values of A and B and C. So we need to find out the largest among the three numbers. So I'm giving a condition here. So if A is greater than B, so this is how I have given. But my logic, you can also construct your own logic. My logic is to, you needn't write the algorithm like how I have written. Your logic can be different, but I just wanted to demonstrate the nested if and else. So I'm picking up this logic. Okay, fine. Okay, so this is my nesting of if. So wherein I said A is greater than C. So you can see that this one is the outer one and this one is the inner one. Okay, fine. So now whatever you want to write, you will be writing over here, and proper indentation is the trick over here. So it is very important that you put the proper indentation. Okay, so I'm saying A is largest. So I'm just writing that statement here. And then coming to the else part over here, so I'll just write the print statement, which will say C, right? Okay, C is greatest because B, A is greater than B. If not A, then it will be C, right? Okay, fine. This is regarding the if and else. Now let us look into if B is greatest. So you need to check on whether B is greater than C. If B is greater than C, then of course B will become the largest. So I'll just need to mention that. And if this condition becomes false, then C is largest. So I just need to write that in the else part. Okay, fine. Um, so this is my simple logic to find out what is the largest among the three given numbers. So this is the outer if and this is the inner if. To just give you the path, what becomes true and false. If this if becomes false, then the control comes to the else part and this code will execute. Okay, so if this condition is true, then this the control enters into the if block, and this code will get a chance to execute. Okay, fine. Once it comes inside, again it checks for this condition. If this condition is true, this print statement executes. If this condition is false, then this else part will execute. Okay, for this else part to execute, this should be true and this should be false. For this part to execute, this should be true and this should be true. Okay, fine. For this print to execute, it should be false and it should be true. For this else to execute, it should be false and it should be false. Okay, right. So this is actually the decision of which statements to execute and which statements not to execute will entirely depend on the conditions here. And the conditions, we do not know what will execute, but we are seeing it to a point that the program will execute to the correctness. Okay, right. So the correctness of the program is that whatever values I give for A, B, and C, I need to get a proper output for it, stating which is the largest. If it is A, I should get A, B, or C. Whatever is the largest I should get. For that, we just have constructed this program code. So let me execute this and show it to you. So I'm saying Python 3. Okay, so what's the name of the program? dec.py. Okay. Okay, so let me execute this. So I'm giving 12 for A, 5 for B, and 21 for C. So you got 21 is largest. Okay, fine. Now we need to debug it for the other one. Okay, so let me say I should be getting 34. Yes, the path is correct. And then I just wanted to check for B also. So which is I got 2 is the largest. Okay, fine. So all the code that we have written, the algorithm is correct, and the concept that we have written is also correct. So this is the second experiment that we have seen, wherein we just have worked out with nested if and else. Okay. So that's it with the decision making. So now let us move on to the looping constructs. I'm taking the same file. So what are the looping structures? Okay, so you do have two looping structures. One is while and the other one is for. Okay, so I have discussed this while and for in your theory part, and also I have shown you certain volume of examples pertaining to while and for, and also we have seen how to nest while and for, and all that stuff is over. Okay, fine. So herein I am just demonstrating an example of while loop. I'm picking on the basic classic example of while, which is check whether a given number is prime or not. So I'm just trying to do that. So I have num here. So I'm taking a number. So num is equal to, so just reading the number. So I'm saying num is equal to int. Then I said input. The very important point to understand is that a prime number is a number which is divisible by 1 and itself only. So we know that 7 is a prime number which do not have a factors other than 1 and 7. Okay, so but if I just take any non-prime number, say for example I take 9, which is a non-prime number. So for 9, the factors will be 1 and also 3, and I do have 9 itself. Okay, so wherein so this is actually the strategy, but one point that I'm just trying to convey is that every number is divisible by itself and 1, even if it is prime or non-prime. So checking for 1 and checking for the number itself, you can avoid it in your coding. Okay, so you can avoid it with your coding. Say for example, I'm taking some other number which is 4. Okay, so for 4, obviously any number, it is divisible by 1 as well as say 2, and then so I do have 4 itself. Okay, so if you can observe, this is a prime number, and 9 and 4 are non-prime numbers. But you can see that every number is divisible by 1 and itself. Okay, 1 and itself. 1 and itself, every number is divisible. So you needn't check for 1 and itself. Okay, so that will actually increase the time complexity. So you can reduce these iterations of checking for 1 and itself, because every number is divisible by 1 and itself. What you can do is we can actually do by checking from 2 till n minus 1. Okay, so your loop can turn from 2 to n minus 1. While checking for this particular from 2, 3, 2, 3, 4, and 5 until n minus 1, if you find a factor, okay, so if you find a factor, the first factor, whatever it is, if the moment you find a factor, what you will do is come out of the loop. Okay, so this is the algorithm. I'm just telling you the algorithm. Factor, come out of the loop. Okay, so there is no point in staying in the loop. So how do you come out of the loop? You can use a break to come out of the loop. And how do you know that the loop have executed through the fullest, okay, till n minus 1, or the loop have come out of the loop came out. Okay, so the loop came out because of the break statement. So this you can use an else after your for, or to check whether a break is executed because of that you came out of the loop, or because of something else. You can actually have many adaptations for that. Okay, but here in my program, what I have done is I have taken a flag. Okay, so I'll initially put the flag to be 0, and the moment I find a factor, what I'll do is I'll change the flag to 1. Okay, this will be an indication for me that the break executed. Okay, so to know whether the break executed or not, I'll be checking with the flag. Okay, so the moment if the flag value remains 0 itself till the end of the execution, it means that there are no factors, and then I'll say it is a prime number. The moment I see that there is the flag have set to 1, it means that it is not a prime number. So this is my algorithm. You can also run it till the half of n by 2. So there are many adaptations for the prime numbers. I'm giving you the basic one. And also in numerical theory, okay, so there is a subject called as number theory, wherein you need to find out, for example, in computer networks and all that, we'll be generating the key, right? I think all of you know what is meant by a key. Key means that which is your password. Okay, so the key to your account is the password. Okay, so you cannot, nobody can access your account without knowing the password, and the password only you know, right? So that for the generation of the passwords and all that, there will be an algorithm which will see to it that no two passwords match, and which is into certain conditions and all that. For that, what they do is they actually generate a prime number, which is a large prime number. Okay, so which should be a large prime number. Large prime number, for example, imagine that you want to execute, you want to find out whether 1, 2, 3, 4, 3, 4, 5, 6, 7, 8, 9, and then I'm saying 3 is a prime number, because we know the concept that we learned it in our school, that prime numbers are odd, but all odd numbers are not prime. So first check whether it is an odd number or even number. There itself you can rule out whether it is a prime number or not. But if it is an odd number, then the picture comes in whether to check that whether this is prime number or not. If you adopt to the algorithm that I told you, that you have to run through you have to run from for this particular number. Say imagine that this is your n. So you have to run through 2 till you have to run through 1, 2, 3, 4. Then you have 2, 3, 4, 5, 6, 7, 8, 9, and 2, right? N minus 1. So imagine if each and every iteration of the loop, I think you're learning it in your data structures. I needn't tell you all that. So this much time it takes to execute. So this is an inefficient methodology. But we illustrate it, the algorithm that I am illustrating you is the basic one. Here the concept is not to write an efficient algorithm, because if I start giving you the efficient algorithm, the essence of learning over here will be missed. That's the reason why I'm giving you the basic prime number program. If I start giving you the efficient one, then we will be deviating from the concept of learning while loop. Okay, so that's the reason, because there will be many things, code will start becoming complex, and I don't think so you will be able to understand the while loop. So that's the reason why I'm sticking to the basic version of finding out the prime number. Is this clear to everyone in the class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
ఇంకా 6 క్వశ్చన్స్, 6 or 7 క్వశ్చన్స్ మీకు మెయిల్ చేసేనా? ఓకే, జస్ట్ a minute girls, give me a minute. రెండు తీయాలి. అందరికీ పెట్టారా? సరే అయిపోయిందిగా, వచ్చిందా? Okay, girls, can you hear me?
Yes, ma'am.
Yes. Okay, so this is what we are going to do now. We are trying to check whether the given number is prime or not. Okay, fine. Well, so for that we are reading the input from the user. The user will be given the number. It can be a prime or it needn't be a prime. It can be a prime number or a non-prime number. So we need to tell the user. Okay, so the number you have provided is prime or not prime. We need to tell the user. Okay, so that's a task. So the input for this particular program will be a number, which will be a number. Yeah. Okay, so the input into this particular program will be a prime number, and the user will be our program needs to check whether the given number is prime or not. So the output will be telling whether the number is prime or not. For that, as I already said, that I'm taking in a flag. Okay, so it can be a boolean value or it can be an integer ఏదైనా తీసుకోవచ్చు. So I'm taking in a boolean value. So initially I'm making it false. You can also put a 0 and make it 1 inside the program. Okay, so nothing wrong in that. Okay, fine. So first thing is I am checking whether the number is greater than 1. Okay, so if it is greater than 1, so now I'll get into the logic. So I am setting I is equal to 2. As I already told you that we are checking for whether there will be factors that exist between 2 to n minus 1. So that's the reason why I have taken another iterative variable, which is I, and I have made it initialized it to 2. Okay, fine. So now I'm turning in a while loop. So I'm saying while. So inside while I am checking till I becomes less than number, meaning that n minus 1. So you can see that, let me give one more indentation. Okay, fine. So here you can see what all I explained you right now is happening in these 2 lines of code. Okay, so I said I is equal to 2 till n minus 1. Okay, I less than number means that number minus 1. Okay, so it rates till number minus 1. So now what I'm doing is, inside this I'm checking for whether there are factors or not by looking into the if condition. So inside the if condition I'm saying num mod I. So if this returns a 0, okay, it means that it is divisible. Okay, fine. So that I'm checking. If this condition becomes true, then I am setting the flag to be true. Okay, fine. So this is what I'm doing over here. If there and also I need to break from the loop. I already told you that there is no point in proceeding further. ఒక ఫ్యాక్టర్ ఉన్నా కూడా అది నాన్ ప్రైమే కాబట్టి so there is no meaning in proceeding further. Once flag is set to true, you just break out of the loop. Okay, else if the condition is not true, then what you have to do is you have to iterate through the loop by incrementing the value of I. You do not have plus plus and minus minus and all that increment and decrement operators in Python like in C programming. If you want to increment, you just have to say I is equal to I plus 1. Okay, well, fine. So this is the logic we have written, a very simple program. And here I'm saying flag, if a flag, okay, meaning that if it is true, then what should we write? It's not a prime number, right? Okay, so that's what I'm writing over here. I'm saying print the number. So where is the number? Number is in num variable. So I'm saying num and then is not a prime number. Okay, so is not a prime number. So this is what we are texting the user, and else we are saying that it is a prime number, meaning that flag is false. Okay, so if flag is still false, it means that this if condition didn't become 0, meaning that there are no factors. Okay, and the loop also executed to the fullest. It means num minus 1 daka loop execute ayinatte. So here we are saying is a prime number. So this is a very simple program to check whether a given number is prime or not. So let me execute, save this, and show you the execution part. So this is your terminal. Can you see the terminal, girls?
No, ma'am.
No? Okay, why the terminal is not visible? Okay, now?
Yes, ma'am.
Okay, so now I'm entering a number. So I'm entering 7 to see. Okay, 7 is a prime number. So check for non-prime also. So I'm giving 12. It is saying 12 is not prime number. So our program is absolutely fine. Okay, now let us write another program. So wherein to check whether it's not to check the Fibonacci number. We'll generate the Fibonacci series. So I'm getting back to the same program, and here the thing is I'm working on the second looping construct, which is for loop. Okay, fine. So to do that, I'm taking the seed values. The seed values are a is equal to 0. For the Fibonacci, these are the seeds of the Fibonacci, 0 and 1. From here, the series grows, right? So from 0 and 1, the series grows because according to the formula of the Fibonacci, okay, so the Fibonacci number is the sum of the previous 2 terms. So we need to know the 2 terms initially. So A and B, 0 and 1 are the initial terms which are considered to be seed 1 and seed 2. Right. And after that, what I'm doing is I'm reading in the number. So since we are generating the Fibonacci series, I just wanted to know till where I have to generate, till which term I need to generate. So I am just taking in the input from the user to know till which term the user wants the Fibonacci series. Fibonacci series are also used in computer networks for various reasons in various algorithms. Okay, so here I'm taking n is equal to input and int, and I'm taking an integer, reading an integer, which decides the number of terms that you want to print. Okay, So well, here I'm saying if n is equal to 1 or n is equal to 0, so there should be a colon here. So then for print n. Okay, so I'm just printing n because there is it means that the user just wants the first seed or the second seed. So I'm just trying to print that over here. Okay, right. And else what I'm trying to do is meaning that the user have given 2 or something. Okay, meaning that the user wants the first 3 terms. Okay, so I'll just print that over here in the else part. Okay, fine. So as I already told you that n decides the number of terms. Okay, how many terms you want to print on the screen. So here print a comma b, and then I just want to separate them over here. So I'm saying end is equal to, so I'll just put a space. Okay, fine. And now I am turning the loop. Okay, for I in range. Okay, so this is what is the syntax of how you need to write a for loop. So you just need to give a keyword which is for, and I is the iterating variable in the range that you mentioned here. Range is a function, inbuilt function, so which will be having as of now we are giving 2 variables here, 2 arguments inside the range function. So I'm giving 2 comma n, meaning that I will start with 2. I will start with 2 through n minus 1. Okay, so that is what we have mentioned. It is similar to, so let me tell you this. It is similar to like I'm initializing I to 2 and then turning the while loop of for I is less than till n. So it is as similar as this. Okay, so then I'm saying I is equal to I plus 1. Okay, so the same thing we have done in a single line. Okay, so I have said I is equal to 2 and I said I is less than n, and I increment over here. So this 3 steps of initialization, condition, and the increment and decrement, that forms the looping constructs of while or for or anything. Here I have done all the 3 things in a single line, wherein I said I first gets initialized to 2, then the condition executes for from the numbers from 2 to n minus 1, meaning 2, 3, 4, 5, so on till n minus 1. Okay, and automatically it gets the next number and all that. Okay, so this is what is your for loop. Girls, hello. Girls, can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes, I just will be back within 2 minutes. This is not on my personal note. They're calling me to the exam cell for 2 minutes. I'll just go and come back. Okay. So meanwhile, you can just take a quick break, or else you can also execute the programs that I have told you. Okay. Practice them. I'll be coming within 2 minutes. Okay.
Okay, ma'am.
Okay, ma'am.
Okay, girls, is my voice audible?
Yes, ma'am.
Yes. Okay, so this is how you are writing your for loop. So inside this, I'll be computing the logic of Fibonacci number. How do you compute the Fibonacci number? So which will be the sum of previous two terms. So I'll say C is equal to A plus B. Fine. Okay. And after printing the Fibonacci number, now what you have to do? You have to change the seed values. How do you change the seed values? B will go into A. Okay, so I'm saying A is equal to B, and then C will go into B. Okay, fine. So this is how you generate a Fibonacci number. Okay, in a particular range. So I'll just print C, and then I'll give a space. Okay, and is equal to this one. Okay, so that's it. So this is a simple for. I already explained to you like what is this for, and let us save this and execute this program. So can you see the screen, all of you, the terminal?
No, ma'am.
Huh?
Yes,
Okay.
ma'am. No. Yes, ma'am.
Okay. Terminal is visible. Okay, so now let me execute this. I want till 5 terms. So you can see that I got till 5 terms. Okay, so 0, 1 are the seed. So 0 plus 1 is 1, and 2 is obtained from summation of the previous two terms. So this is n minus 1 term, and this is n minus 2 term. So 1 plus 1 is equal to 2. And then 3 is obtained from 2 plus 1. Okay, so this is how you can generate the Fibonacci series. If you want it till 10, so you'll be getting the Fibonacci sequence till 10 terms. Okay, right. So this is your your third program. Okay, your third exercise is complete now. So let us look into what is your fourth exercise. So your fourth exercise is to write a program to demonstrate working with lists in Python. So this is నేను క్లాస్లో ఉన్నప్పుడే వీళ్ళకి అన్ని గుర్తొస్తాయా ఏంటి? Okay, can you see this Word document?
Yes, ma'am.
Okay, so this is the fourth experiment. Just take a look at the fourth experiment. So which is write a program to demonstrate working with lists in Python. Okay, so I think the color is too dark for you to identify. Okay, fine. Just look at the experiment. So it is saying write a program to demonstrate working with lists. List. Okay, fine. So I'm taking the same file. Okay. Right. So you know that list is a mutable data type. So I'm just taking a blank list over here. So this is how you create a blank list. Okay. So this is a very general program where they ask to write a program to demonstrate working with lists in Python. So they didn't mention the methods or the functions that operations that you apply on list. In your internal and external lab examination, we can give you certain operations, okay, specifically. We can ask you to access the list elements. So that kind of questions you will be getting. So I'll be showing all the list operations here in a single program. Okay. So this is how I'm creating a blank list. So I said print. So this is how you need to write down. Okay, so in the .py file you need to write everything and then save and quit from this particular text editor, and then get back to your terminal and then use the command python 3 and then followed by the name of the file, enter, then you will be getting the output. Okay, so I just wanted to show you the output straight away. So that's the reason why I'm quitting from this particular terminal. I'll get to your Chevron prompt, and then I think you can just look into the output straight away. So I prefer going into that just for the demonstration sake. Okay, so I want you people to not get confused and look into the output straight away. So I'm coming over here. Okay, so I can say L is equal to, so herein I'm just creating an empty list. And if I say print L, so let us see what will be printed on the screen. So you can see that an empty list is printed. So I just wanted to show you the output straight away. So that's the reason why I'm opting for this interactive mode. Else in the examinations, you should be writing in the single file. Okay, I think that part is clear, right, to everyone?
Yes, ma'am.
Yes. Okay. So now I'm taking a string inside a list. So list can contain anything. Okay. So I'm saying in the previous case it's an empty list, and now I'm having a list of strings. Okay. So I'm saying see Sudha and Python. Okay. So this is a list with strings. Okay. Fine. So this is also possible. So I can simply say print, and then I'm saying L. So it will just print the list for you. For your MCQs and all that, I and Sinu sir were preparing your examinations MCQs. So wherein see the syntax of these things are very important, like what will be the output of certain programs. I have given couple of not couple, I have given more than couple of programs inside your MCQs. So which you need to really be thorough with the syntax, else you will not be able to answer it. Okay, so your MCQs are over. I was just making that in the morning. I and sir was making that in the morning. So that same MCQs everybody will get. Even the other sections also will get the same MCQs that I am preparing. I and sir are preparing. So I'm telling you before itself that you need to be syntactically correct, syntactically strong to answer the questions. Okay, so this is wherein I have a list with strings. Okay, fine. I can also extract the uh, I mean element at a particular index. So if I just say that I want an element at L of 0, so this is just like indexing is given to the elements in a list. So this will be at 0th element. Sudha will be at 0th element index, and will be at 1, and Python will be at. Okay, so if I just want to access the elements with the index number randomly, I can do that. Okay, 0, 1, and 2, right? So I'm saying 2, then I get Python. If I try to give L of 5, what will be the answer? What will be the output when I say L of 5? Anyone would like to answer this?
It is not in the script.
Index error, ma'am.
Index error.
Very good. I'll be getting an index error. Very good. These you can find such type of questions in your MCQs. See, I'm giving you certain clues also, like how your MCQs are gonna be. Okay, so like this kind of questions I have given. Okay, so I'll be getting an index error. If you're trying to access the elements in a list which are not there, then you'll be getting an index error. Okay, fine. So this is regarding accessing the elements directly using the index number. In the similar way, how to create a list with mixed types of values. So let me just show you that. So I'm saying L is equal to, so I'll take an integer, so 1, and then I'll take an floating value, so 4.5, and then I'll take a string, which is Sudha, and then I can have combinations of anything. Okay, right. I'm just taking these things, okay, and if I just wanted to print this, I'll be getting the answer like this. Okay, fine. So now let us look into how to use a for loop to access the elements of a list. So for that, what I'm doing is I'm taking a list. So I said L is equal to So I have taking some integer elements into it. So 4, 3, and 8, and 5, and all that. And next, what I'm doing is I am trying to print this. So you can see 4385 is printed on the screen. And now let us try to access the elements of the list. Okay, so I'm saying for I in range. Okay, fine. So it is from 0 to 4. Okay. So, and then I'm saying print. Okay, L of I, comma, and is equal to, okay, fine. Okay. Okay, so it's difficult for me to do it here. Okay, fine. So I'll show it here. So I'm taking L is equal to, so 4, comma, 3, comma, some 7, comma, some 12, or whatever. I just have given this. So if you want to print, you can just print the L, give L inside the print statement. And now I am turning a loop. So I'm saying for I in a range. Okay, so what is the range? So the range is from 0. Okay, so index starts with 0, right? 0, and then 4. Okay, meaning 4 minus 1, which is 3. Okay, fine. So this is my for loop. So inside the for loop, I'm just printing the elements of the list. Okay. So the name of the list is L, and the index number is navigated through an iterative variable I. So I said L of I, and then I said end is equal to. So I just wanted some space to be given to in between the numbers, so I'll just do that. Okay, so now save it, come out of it, and let us execute the program. So Python 3 and then dec.py. So you can see that, so these are the numbers that are there in the list. This is the output when I said print L. Okay, so when I say print L, this will be the output. But when I navigated it through the for loop, then this is the output. Okay, fine. So let me get back to the program again and do the rest of the operations. Okay, fine. So in case if I want to find out the even, bring out the odd squares. Okay, so from the list of the elements that are there in the list. So I'm just taking another a list which is odd square. Okay, so I'm saying odd square. So this is the name of the list, and here I am taking a for loop. Okay, wherein I am doing the power of x if it is an odd number. Okay, fine. For x in range. So what it is, x in will be taking the list directly. X in L. Okay, if x mod 2 is equal to 1. So we want the odd squares, right? So I want to first find out the odd numbers and then do the power of square of that odd numbers and put that in a list which is odd square. Okay, fine. So now if you want to, this is what is the concept of list comprehension. So you may get this. Okay, so in your internal and external lab examinations, I may ask you to write a program for demonstrating list comprehensions. Okay, this is an example of that. List comprehension. Okay, what is this? Navigating a list, or you can say accessing a list, accessing elements of a list. Okay, of a list. Okay, so this is that concept, and this is list comprehension. Okay, so how this executes is, first what it will do is it will extract x from L. L is the name of the list over here. So 4 is taken. So 4 mod 2, which is resulting in a 0. Okay, so this condition has become false. When this condition became false, this will not execute. Okay, so this will execute only if this becomes true. So now it gets into the next element. So the next element is 3. Okay, So now 3 is now in x. Okay, so x mod 2 is equal to 1. So this condition is true. So now 3 square. Okay, so 9 will be there. And in the next case, 7 is taken. So 7 is an odd number, 7 square, 49. And then 12, 12 is not an odd number, so it will be skipped. And this is over. Now, if you want to print what is there in odd square, you will be seeing a list. Okay, so let me just print odd square for you. Okay, so let me execute this for you and show. Okay, I should put a square bracket there. I have put a parenthesis. Okay, so you can see that this 9 and 49 is the odd square. Okay, so this is the result that you have obtained after list comprehension. Is this clear, Ma?
Yes, ma'am.
Yes. Okay, now let us do more operations on the list. Do you want me to keep this or you want me to delete and do more operations? Else you will be getting confused if I keep this.
Delete, ma'am.
Okay, I'll delete and do the operations for you. Okay, else you'll get confused. So in the similar way, I can also have duplicates inside a list. So I have 1, 2, and then I am giving 4 and a 4, and then 3 and a 3 and a 3 and a 6 and a 5. Okay, so this is to demonstrate that list can have duplicates. Wherein your set cannot have duplicates. Okay, so that's the difference, to just show you what are the qualities of a list and what are the operations that you can perform on a list. This is an example. Okay, so the list can contain duplicates. If you just print L, it will just print what what are the elements inside a list. In the similar way, I can use a function which is called as the len function. Okay, so which will actually find out the number of elements inside the list. Okay, so I'm using the len function. So here in I say len, and inside this len I am passing the name of the list. Okay, so the name of the list is L. So in the similar way, I can also sort the list. So I'm using L dot sort, which will actually sort the list. And after sorting, let me print it and show it to you. So wherein I'll say after sort, okay, or it's the sorted list. So which will actually show you the sorted list. We may ask you the combination of operations under. So each and every operation you need to be thorough with. And then I am saying list dot L dot sort. Okay, so L dot sort, and now what I'm doing is I want to do the reverse sort. So I'm saying reverse is equal to true. Okay, so when you say this, what happens is like it will be reverse sorted. So let me give the print statement here. Okay, so reverse sorted list. Reverse sorted list is L. Okay, fine. In the similar way, you can append certain values. First, let me show you these operations and we'll come back to the more operations. So you can see, girls, that this is the list that I have taken and the length of the list is 9. You can see that there are 9 elements here. Okay, 1, 2, 3, 4, and then I have 4, 8, and then 9. Okay, so this is length. And then because these and all you can get it in your MCQs, what is the method that is used to find the size of a list, or all that you can get. So these are very, very important things to fetch more marks in your MCQs. Not only that, for your lab session also, these can be asked in a bit wise. Okay, I can ask 2 or 3 operations together as a single program. So learning all operations is important. And then coming to the sorted list. Okay, so this is the sorted list. You can see that 5 have come before 6 and 3 have come before 4 and all that. So the elements are put in sorted order, and this is the reverse sorted list. Okay, so I have 6, 5, 4, 4 and all that. These are the operations. Okay, fine. Now let us get back to our program and do more operations wherein I am removing this length sorted and reverse sorted. Now I'll show you how to use the append operation. Okay, so I can simply say L dot append, and I'll be adding a number. So I'll add 100. Okay, so L dot append 100. Okay, so I'll add this and I'll show you what will be the output of it. Okay, fine. So I can say print. Let me be clear on this because we'll be doing 2 or 3 operations to know like which operation have produced which output. So I'm writing some text here in the print statement. So I'm saying after appending 100. Okay, fine. So how the list is, so which is L. Okay, so this is one of the append operation, and in the similar way I'm saying L dot insert. Okay, so I said L dot insert, and then this will take. Okay, so I'm saying 3 comma 12. We'll see what will happen and in which position it is inserted and all that. You will be making it out. So I'll be giving the list for you over here. So this is after insert. This is after insert. Okay, fine. So let me save this and show you the output. Okay, so this is your list, mark. So this is your list, and I said after appending. So you can see that append operation adds the element at the end of the list. So 100 is added at the end of the list. And coming to insert operation, so we said 3 comma 12, right? So 0, this is 0, this is 1, and this is 2. And this is the third position. So at the third position, you're inserting 12. Okay, I have given 2 digits so that you'll be knowing like where it has insert rather than giving 3, 4 and all that, because you may get confused if I give 3 and 4. So that's why I gave 2-digit number here to make you understand that at which position it has inserted. So append will add the element at the end and insert will add the element at a concerned position. Okay, so you can mention the position first. These are again the MCQs. Like when I say like insert, the first argument is what and the second argument is what. So such kind of questions you may get. Okay, right. So I'll be showing other operations like extend and all that. Now I'll remove all this and I'll say L dot extend. Okay, so L dot extend, and here I'm giving something. So I'm saying 82. So I need to give the list. So I think you know this, right? So I'm saying 82 and Sudha, and I'm putting so this is a list. So I'm just extending the list with this list. Okay, fine. And so let us look into the operations of the negative indexing. So I said print. Okay, so let me say this is so L minus 2, and then I'm saying minus 2. Okay, fine. So this is negative indexing, and we'll see what will be the output of this. Okay, fine. And in the next case, I'm showing you another operation, which is the remove operation. So I'm saying L dot remove, and I'm asking it to remove element 5. Okay, fine. So these are the 3 operations. We'll be seeing the output now. Okay, fine. Okay, so you can see that I think I didn't print the list after extending it. Okay, so this is the list, and let us. Let me print this. Okay, so you can see this that okay, look at this, girls. Okay, so this is the list now. So we have appended it with 82 and Sudha. So this is an extension of the list. So this is the first list and this is the second list. We are just joining it together. And negative indexing is where it starts counting from the last. This is -1 and this is -2. So -2 will print 82 for you on the screen. And in the next case, what I did is I asked it to remove 5 from the list. So 5 has gone from the list. So you can see that 5 no longer exists in the list. So these are the operations of negative indexing as well as the remove operation and also the extend operation. So let me show you a few more operations and we'll the fourth exercise will be over. So just I'll take just 2 or 3 minutes of your time and I'll close it. Okay, so let us get back to the program and we'll see what is a pop operation. Okay, fine. So I'm saying L dot, so I have L dot pop. And I think I have used this pop operation and all that to show you the stack implementation using list. So you can just connect it to that concept and understand. Okay, so this is pop operation. So I'm just saying after pop, which is L. Okay, fine. And the next operation I would like to show you is the slice operation. So I'm saying print. Okay, this is slicing. So the sliced list 5 colon. Okay, I have given this to make you understand what is the operation performed. And then I'm saying L. Okay, 5 list. Okay, fine. Okay, this is what I have done.
Ma'am,
yes.
ma'am, if we give from 2 to 5 means what is that?
Yeah, you can give it. Okay, let me give 2 to 5. Huh?
Yes, ma'am.
Okay, so this is the pop operation and the slice operation. I'm doing that. Okay, so I also can take another list which is S. S is equal to, I can say L dot. Okay, so to make it more readable to you. So I'm saying 2 to 5, you said, right? Okay, so I just have put it there and this can be S. Okay, after slicing, you can say after slicing. Okay, sliced list. Fine. Okay, fine. So let me execute this and show you. Okay, so you can see this is the slice list. So you want from 2 to 5. So it has sliced it and it has given you the list. Okay, this is after pop. So you will just have pop first in first out. So the last element, if you want to pop it, you will be using the pop operation. So the last element is gone and this is the sliced list. Okay, right. So this is regarding slicing. And remember that one important point is that after slicing, you'll be having the original list itself. Slice is like you are just taking a part of the list and putting it in another list. But if you want to print the list again, L again, the original list will be there for you. Okay, it's not cut off from the list. That's what I want to say. Okay, fine. This is these are all the operations that you can perform on the list. And let us now look into creating a multi-dimensional list. So this is the last part that we are going to do in the list operations. So what I'm doing is I'm taking a list. List is equal to, I'm taking a multi-dimensional list. I'm taking 2 lists over here. The first list I'm saying Python. Okay, so which is a string. Okay, the list of strings. Okay, fine. So this is the first list and this is the second list wherein I'm saying it's also having some values like this. So I'm saying CSC. Okay, fine. And also I can have some numbers, so I can say 100. So I already showed you the a list with mixed values, right? So I think you should not get a doubt that whether I can have a mixed values or not. So this is how you create a multi-dimensional list, which is also called as nesting a list inside a list. Okay, so this entire thing, this bracket over here and this bracket is the entire list, and this is one dimension and this is another dimension. So I'm having a list inside a list. Okay, fine. So if I just wanted to print it, let us see how it looks in the output. So I'm saying print list, so that this will show you the output. Okay, fine. So how do I access a particular element in the list? Especially a multi-dimensional list, what I'll do is I have to do it in such a manner. So let me show you that. So I said list, and then I'll be going, this will be 0 and this will be 1. Okay. So if I wanted this again 0, 1, 2 and all that. So I can say 1, comma, I can say 0. Okay. So it will retrieve the concern element for me. Okay, so let us see the output. Okay, okay. Okay. I should give it in a 2 dimension, right? The 2 dimension. So I just need to give it in a 2 dimension, right? Well, you can see that. So this is how I have created a multi-dimensional list, wherein this is the first list and this is the second list. And as I said, this list will be considered to be 0, like how normal indexing of your regular list. Okay, and this will be 1. Okay, so this entire part will be the 0 element, and this entire part will be the first element. And inside the 0 element, each and everything will be like, this will be 0, 0, and this will be 0, 1, and this will be 1, 0, and this will be 1, 1, and this will be 1. Okay, so if you want to extract a CNO, so as I already told you while writing the program, so this is 1 and a 0. Okay, so this is how I extract the elements at a particular in your array. Okay, you have how do you access the element? So if it is 2 dimensional, you'll say the first dimension will be for the rows and the second dimension will be for the columns, right? In the similar way, like you will be accessing the elements from a list. Okay, so that's it. Your fourth experiment is also over. I hope all the operations are clear. So what are all the operations that we have seen? Let me just give you a recap of all the operations that we have seen. So first we have created an empty list, and then I showed you how to create an empty list, and then I showed you how to access the elements of a list by using the index number, and later on I showed you how to create a mixed type of values in the list. And then we have seen the operations. We have seen, I think I have written the for loop, right? Next I have written a for loop, and I have shown you how to access each and every element of a list. And then I have shown you list comprehension. In the list comprehension, I have taken the list odd numbers from the list, and I have done a par of a square of the odd numbers, and I have put the squares in a separate list, and I printed the resultant to you. And then I have created a list with duplicate values. So that is possible. A list can have duplicate values. And then we have seen the operations of finding out the length of a list, and also sorting of the list, and reverse sorting of the list. And then we have seen append operation, insert operation, and finally we also have seen extend operation. And then we have seen negative indexing, and then the remove operation, and then the pop operation, and then we have seen how to slice a list. Slicing will not cut off the sliced portion from the original list. The original list will be as it is, but you can actually take a portion from the list by using the slice operation. And then we have seen multi-dimensional list. Nesting of a list inside a list is also called as multi-dimensional. And I have shown you how to create a multi-dimensional list, and also shown you how to access a particular element in a multi-dimensional list. Okay, fine. So these are all the operations that are pertaining to a list. So exercise is over. In the coming lab sessions, I will move on to the next lab programs, which are like working with tuples and then dictionaries and then modules and all that I'll be showing in the next coming class. So I hope today's class is clear to everyone.
Yes,
Yes,
ma'am.
ma'am.
Yes. Okay, fine. I'm leaving the class. We'll meet up again tomorrow.